In section 3.3, we are going to calculate probabilities using counting methods. That means that we are going to use some of the content that you learned in chapter 2. You may be able to use the fundamental counting principle and techniques involving permutations and combinations to solve probability problems with many possible outcomes. The context of each particular problem will depend on the counting techniques you will use. You learned in section 2.7 to distinguish between those questions that were permutations questions and those questions that were combinations questions. Those same things apply here. We will use permutations when order is important. In other words, we are finding the likelihood of a certain arrangement. We will use combinations when order is not important. In other words, we're finding the likelihood of a certain group or selection. The way that the questions are asked in this section are going to be different than the way that they were asked in chapter 2. In chapter 2, you were always asked, in how many ways can you arrange something? In how many ways can you select something? In chapter 3, you're going to be asked, what is the probability of a certain arrangement? What is the likelihood of a certain selection? So the wording of the question is a little bit different. What remains the same is that when we're finding the probability of any event A, it is still going to be equal to the number of favorable outcomes out of the number of total outcomes. In this section, the number of favorable outcomes is going to come from the number of permutations or combinations with the given restriction. And that restriction will be given in each question. That's what you want to find the likelihood of. The number of total outcomes comes from the number of permutations or combinations with no restrictions. The total number of permutations or combinations possible with a number of items you have. So permutations and combinations with the given restriction becomes your numerator. Permutations and combinations with no restrictions becomes your denominator, and that becomes your probability. Let's look at our first example. Gwen, Morgan, Arthur, and Jay are trying out along with 5 other students to be on their school's swim relay team, which requires 4 swimmers. All the students have equal ability. Determine the probability that Gwen, Morgan, Arthur, and Jay will be selected to fill the 4 spots on the team. We can see that we have a selection here. We can also see that Gwen, Morgan, Arthur, and Jay are not given a specific order or specific position to fill. This is strictly a selection, which means we are talking about a combination. So we will use combinations to help us calculate. You'll also notice that the question doesn't ask in how many ways can they be selected. The question is, what is the probability that they are selected? Probability is the number of favorable outcomes out of the number of total outcomes. Our favorable outcomes is going to be the combinations with the restriction we were given. The restriction is that Gwen, Morgan, Arthur, and Jay are on the team. So our favorable is the number of combinations that has our friends. The number of combinations that have Gwen, Morgan, Arthur, and Jay. Our denominator is the total number of combinations with no restrictions. So that's going to be the number of combinations that have any of the students trying out. Well, Gwen, Morgan, Arthur, and Jay are trying out with 5 other students. There's 9 students here. So the number of combinations that have any of the 9 students. Let's put that in the combination form. The number of combinations that have Gwen, Morgan, Arthur, and Jay, well, of those 4 students, we want to choose those 4 students. In the denominator, the number of combinations that have any of the 9 students, that means out of the 9 students, we are choosing 4. Let's go ahead and calculate those numbers on our calculator. 4 choose 4 gives you 1. 9 choose 4 gives you 126. And there is your probability. So the probability that Gwen, Morgan, Arthur, and Jay are on the team is going to be equal to 1 out of 126. Let's look at part B. Part B says Gwen is scheduled to be the first swimmer and Morgan is scheduled to be the last swimmer on the team. Well, now we are giving very specific positions to the 2 girls that we're having on the team. If we're giving them specific positions, that means that order is important, which means that we are now talking about a permutation. So we are going to use permutations to calculate the probability. Probability, one more time, is the number of favorable outcomes out of the number of total outcomes. Our favorable outcomes is the number of permutations with the restrictions we are given. So that is going to be the number of permutations that has Gwen in the first position and Morgan in the last position. Our number of total outcomes is our number of permutations with no restrictions. So that means that's the number of permutations with any of the 9 students in any of the positions. Now, we're only going to have 4 people on the team. So we're only going to write our 4 positions. In the numerator, here's our 4 positions, 1, 2, 3, 4. The first position must be Gwen. There's only one choice there. The last position must be Morgan. Only one choice there. In the middle, we don't care who goes in that second position. We have got 9 students total. We've placed Gwen. We've placed Morgan, which means we have 7 choices left for the second blank and 6 choices left for the third. 1 times 7 times 6 times 1 gives us 42 in the numerator. In the denominator, we still have 4 blanks, but this time we can put any of the 9 students in any position. We have 9 choices for the first blank, 8 choices for the second, 7 choices for the third, 6 choices for the fourth. We multiply those numbers together, and our total in our denominator is 3,024. We could have also written that denominator in a bit of a different way. We could have thought to ourselves, we have the 9 students. We are arranging them 4 at a time. So 9 permute 4, it would give you the same exact number, still that 3,024. So our probability currently is written as 42 over 3,024. So if we go to our calculator and we put that into our calculator, 42 divided by 3,024, and then we want to change that to a reduced fraction, we get 1 out of 72. So our probability here will end up being 1 out of 72. And that's the probability that Gwen would be the first swimmer and Morgan would be the last swimmer. Let's move on to example number 2. Example 2 says that we've got Jamal, Ethan, and Alberto. They're competing with 7 other boys to be on their school's cross-country team. All the boys have an equal chance of winning the trial race. So it looks very similar to the question we had above. Determine the probability that Jamal, Ethan, and Alberto will place first, second, and third in any order. Well, we are definitely talking about a permutation here. We're talking about first, second, and third position. We're talking about order. this is going to be a permutation. Probability is our number of favorable over our number of total. Our favorable comes from the number of permutations with the given restriction. So that's the number of permutations that have Jamal, Ethan, and Alberto in those three positions, in first, second, or third. Our denominator comes from the number of permutations with no restrictions. So that's the number of permutations with any of the runners in first, second, or third. We've got Jamal, Ethan, and Alberto with 7 other boys. That means any of the 10 in first, second, or third. For the numerator, we'll draw our 3 blanks. There's first, second, and third. We're only dealing with Jamal, Ethan, and Alberto. They can come in any order, which means we've got 3 choices for the first blank, 2 choices for the second blank, and 1 choice for the third blank. 3 times 2 times 1 is 6. In the denominator, we still have 3 blanks, but now any of those 10 boys could be in that position. 10 times 9 times 8, which gives us 720 in the denominator. Again, we could have also written that denominator in a bit of a different way. We could have written that denominator as we've got 10 runners. We want to arrange them 3 at a time. So 10 permute 3 would give you the same thing in the denominator. Again, if we want to take that probability and find it as a reduced fraction, then we can take our 6 divided by 720. And then math, number 1, fraction, to write that as a reduced fraction. And we get 1 out of 120. And there's our probability that Jamal, Ethan, and Alberto will place first, second, or third in any order. Let's have a look at part B. Determine the probability that Jamal finishes first, Ethan finishes second, and Alberto finishes third. So we're still talking about probability here. We are still talking about arranging, and we're talking about specific positions and specific order. So our number of favorable outcomes comes from our restrictions in the question. And so our restrictions here are a little bit tighter now. We want the number of permutations where Jamal is first, where Ethan is second, and Alberto is third. In the denominator, it's still going to be the same as the denominator above. That's the number of permutations of any of the 10 students or runners in first, second, or third. So we can say right away that our denominator, we can write it as 10 times 9 times 8, or we can write it as 10 permute 3. Our numerator, though, we have our 3 blanks. Now, this has a specific person. In our first blank, we want Jamal. We only have 1 choice there. In our second blank, we want Ethan. There's only 1 choice there. In our third blank, we want Alberto. There's only 1 choice there. 1 times 1 times 1 is 1. 10 permute 3, still 720. And 1 out of 720 is going to be our probability there. Let's have a look at example 3. A security access code consists of 4 digits. Victor can remember the 4 digits that were used, but he can't remember the access code's order. Determine the probability that Victor gains access on his first attempt without triggering the alarm if all 4 digits are different. So we have 4 different digits, and they have a specific order. So this is definitely talking about a permutation. And we're going to use permutations to help us calculate the probability that he gains access the first time, that he gets it correct. Probability is our number of favorable outcomes out of our number of total outcomes. Favorable outcomes comes from the number of arrangements with a specific restriction. So in this case, that is going to be the number of arrangements of these numbers that are correct. The correct code, the number of arrangements that are correct. The denominator is going to be the number of arrangements with no restrictions. So that's going to be the number of arrangements of the 4 numbers. Let's draw our 4 blanks for our numerator, and let's talk about our number of choices for each spot. Well, in the first position, there's only one number that's correct for the code. In the second position, there's only one number that's correct. In the third position, there's only one number that's correct. And in the fourth position, there's only one number that's correct. 1 times 1 times 1 is 1, which makes sense because there is only going to be one correct code. In the bottom, we're going to talk about the number of arrangements with no restrictions. That means any of the 4 digits can go into the blank. That means for our first position, we have 4 possibilities. In the second position, 3 possibilities. In the third position, 2 possibilities. And in that last position, 1 possibility. We multiply them by each other. You may have also just thought in your head, well, I've got 4 different values and I'm arranging all of them. That would be equal to 4 factorial, and you definitely could do that as well. No matter which way you do it, that denominator is always going to give you that same number, and that's going to be 24. So your probability that Victor gains access on his first attempt is 1 out of 24. 1 correct code out of 24 possible codes. Let's move on to number 4. A photographer wants to display his 7 favorite photographs. 3 of the photos are in color, and 4 of them are black and white. What is the probability that when he hangs them in a row, the black and white photos are beside each other? All right, so we've got 7 items here, and he is putting them up on the wall. He is arranging his photographs. That means that we are talking again about a permutation. So we're going to use permutations to help us to decide what the probability is here. Okay, we want the probability that when he hangs them in a row, the black and white photos are beside each other. So that's our restriction. So in the numerator is going to be the number of permutations where the black and white are together or beside each other. And that's important. Items together. Out of, in the denominator, that's the number of permutations of all the 7 photographs. Okay, the number of permutations of all the 7 photographs in any order. Let's deal with our numerator. In the numerator, we want the black and white photos together. So I'm just going to do a calculation off to the side here. When we put items together, we talk about actually putting them together. So what I'm going to do is I'm going to put a circle around, and inside I'm going to put the 4 black and white photos. So I'm just going to call them 1, 2, 3, and 4. So there's our 4 black and white photos sitting inside. Our other remaining 3 photos, which I'm going to call 5, 6, and 7, are still considered individuals. So we take the photos that are going to be together, we put them together to count as one item, and then the remaining individual pictures stay as individuals. So now, instead of arranging 7 objects, what we are arranging is 4 objects. 1, 2, 3, 4. So that represents our big bubble, which contains the black and white photos, and it also contains the 3 individuals, so 4 things altogether. We're not given a specific order for those items, so it doesn't say that the black and white photos have to come first or second or third. So when I go ahead and arrange the blanks here, I have 4 choices for that first spot. I might put one of the color photos, or I might put the black and white photos there. In any case, once I've placed a picture, I can't use it again, which means we'll have 3 choices for the second position, 2 choices for the third position, 1 choice for the fourth position. Now, these 4 pictures that we have grouped together, they were not given a specific order, so we need to arrange those photographs as well. Those 4 items can be arranged 4 factorial ways. So I'm going to take the arranging of the items and I'm going to multiply it by 4 factorial to show the arranging of the black and white photographs. In the denominator, we are arranging those 7 items any way we want. So you can draw 7 blanks and put 7, 6, 5, 4, 3, 2, 1, or recognize that we've got 7 items. We are arranging all 7 of them, which is 7 factorial. We're going to put those into our calculator. So essentially this would become 4 factorial. So 4 factorial times 4 factorial is going to give us a number in the numerator, and that number is 576. In the denominator, we have 7 factorial, which you can calculate, which would be 5,040. We want to take this number and we want to reduce it. We're going to write it as a reduced fraction. So we go to the calculator and we can go ahead and put in 576 divided by 5,040. Hit the math number 1 button. That's going to change it to a reduced fraction, and we get 4 over 35. So our reduced fraction here would be 4 over 35, and there is our probability. Question 5. A group of 4 athletes is to be selected to go to a session with a physical trainer. There are 10 soccer players and 7 basketball players who want to go. All right, so we are talking about a selection here. It doesn't talk about a specific order or specific jobs or positions. So this is strictly a selection. We are talking about combinations. Now you'll notice that we have a couple of different groupings here. So this is going to be similar to the committee type questions that you would have done in chapter 2, where we're talking about different categories of people and choosing different numbers from those categories. But this time, we are connecting it to probability. Let's read A. What is the probability that exactly 3 soccer players are selected? Probability is the number of favorable outcomes out of the number of total outcomes. When we're talking about permutations and combinations, the numerator comes from the number of combinations with restrictions. So in this case, we want the number of combinations that has exactly 3 soccer players. So 3 soccer players, and because we need a group of 4 athletes, that means we need to have 1 basketball player. That's our favorable outcomes here. 1 soccer player, 3 soccer players, and 1 basketball player. Our number of total outcomes is going to come from the number of combinations with no restrictions. That means that is the number of combinations using any of these athletes. It doesn't matter, soccer or basketball, it's just the grouping of any of the athletes. Because we have 10 soccer players and 7 basketball players, that means we've got 17 athletes all together. So our denominator is going to be the number of combinations using any of the 17 athletes. Let's have a look at our numerator. The number of combinations of 3 soccer players and 1 basketball player. We have 10 soccer players to choose from. We need to choose 3. 10 choose 3. I see the word and, so I'm going to multiply by, well, we've got 7 basketball players and we need to choose 1. There's our numerator. In the denominator, I'm not worried about basketball players or soccer players. I just am worried about the fact that I have 17 athletes and I need to choose 4 of them. That is the total number of combinations. 10 choose 3 times 7 choose 1. You can put that into your calculator. That gives you 840 combinations. 17 choose 4. You can put that into your calculator as well. That gives us 2,380 combinations. There's your probability. Let's take that probability and write it as a reduced fraction, and that gives us 6 out of 17. So the probability that in the grouping of 4 athletes, we've got exactly 3 soccer players, it's 6 out of 17. Part B. Part B says, what are the odds in favor of selecting exactly 3 soccer players? So we're going to take the probability that we found in Part A and convert it into odds in favor. Odds in favor compares our number of favorable outcomes to our number of unfavorable outcomes. The favorable outcomes, well, that's easy to find. That comes from the numerator of our probability. So right away, we can put our 6 there. Well, in the probability, we have favorable and total. So our favorable is 6. Our total is 17. So we're going to subtract those 2 numbers to find our number of unfavorable. 17 minus 6 gives us 11. Put that in our unfavorable spot. There is our odds in favor of exactly 3 soccer players being selected. Part C. What is the probability that at least 3 soccer players are selected? At least 3 soccer players are selected. Okay, so the numerator is going to come from all the combinations of at least 3 soccer players. So we're going to have to consider a few different scenarios there. At least 3 soccer players means that we can have 3 soccer players and 1 basketball player, or we could have 4 soccer players and no basketball players. That's our number of favorable outcomes, or that's where our favorable outcomes are going to come from. Our denominator is the exact same denominator from Part B. That hasn't changed. Our total number of combinations is just the combinations using any of the 17 athletes. So I'm just going to fill this in with 17, choose 4. Let's go to our numerator and figure out what numbers we're going to put there. Well, 3 soccer players and 1 basketball player, we did that above. We know the number of combinations there. That's 840, so no need to write that out again. I see the word or, and that applies addition, so I'm going to put addition in there. 4 soccer players and no basketball players means out of the 10 soccer players, I'm going to choose 4 multiplied by out of the 7 basketball players, we are going to choose 0 of them. In the denominator, we have 2,380, which just comes from calculating 17, choose 4. Adding that up in the top, that gives us 1,050. So we have 1,050 over 2,380. We can put that number into our calculator and get the reduced fraction, and that reduced fraction is 15 out of 34. Let's look at the last part of this question. What are the odds against at least 3 soccer players being selected? So we are going from probability to odds again, but we are looking in this case at odds against. Odds against is the ratio of unfavorable outcomes to favorable outcomes. We have our favorable outcomes. That comes from our numerator of our probability. So we know that favorable is going to be 15. Unfavorable just comes from taking our total number of outcomes, which is our denominator from our probability, and subtracting our favorable outcomes. 34 minus 15 is 19. We put that in the unfavorable spot, and there are the odds against. That is how we use permutations and combinations to calculate probability.